Welcome to day 23 of distance learning. You should have either this packet 5.1.3 printed out or you should be working on line paper. You do not really need to graph anything today. There is one question that requires you to graph, but it's pretty much just a rough sketch. This one at the end. So really you should just be working on line paper or a printout. I'm being quiet right now just because people are still sleeping. So turn your volume up if you need to. So basically, before watching this video, you should have already finished 5-41 on your own. It's 4 problems and you're finding the inverse algebraically. You can use the last video that I made from last week to help you with this if you don't remember, or the past 2 assignments from last week. You just change your function notation to y, switch the x and the y, because the inverse means backwards, so you flip it, and then you're just solving for y. Make sure that when you solve for y, when you're undoing, you work backwards from Pemdas. So we need to get rid of the multiplication, the 2 in the front. So I divided both sides by 2. Your next step is to get rid of exponents or roots before parentheses. So I cubed root both sides to get rid of cubed. And then your last step, now that the parentheses is alone, I took it away, and you just add 1 on the end because that's the last step. And then I change back to inverse function notation with my -1 exponent. If you have any questions on this, you can comment on the YouTube video down below or in Google Classroom. These 3 should have been done. I'm not showing them in this video because I only need 1 example for the following problems. I'm going to flip over to the next page. You were told to use letter A from this example, so I already have it written down. And we're going to do 542 and 543 together. So in 542, it says Adriana's strategy for checking that the functions f of x and g of x are inverses is to think of them as stacked function machines. She starts by choosing an input to drop into f of x. Then she drops the output from f of x into g of x. If she gets her original number, she's pretty sure that the 2 equations are inverses. So it says select the pair of inverse equations from 541a, name them f and g, then use Adriana's ideas to test them. So what I'm going to do is just follow her idea, and since in this next problem she wants us to plug in 3, I'm just going to choose 3 to plug in. So I'm going to choose an input to drop into f of x. I'm going to drop 3. And then I'm going to figure out what that is. So anywhere you see an x, replace it with 3. Okay? This is just notation. This means you're just plugging in 3 into f, so you shouldn't be doing any math on this side. So Pemdas, we start with parentheses first when we are evaluating. 3 minus 1 is 2. Then we do exponents. So 2 cubed is the same as 2 times 2 times 2, which is 8. And lastly, multiplication, 2 times 8 is 16. Now what we do with that 16 is then we're going to drop the output from f and we're going to drop it into g. So I'm going to take my 16 and I'm going to plug it into g. Anywhere you see an x, replace it with 16. Again, this is just notation. Don't do math on the left side. 16 divided by 2 is 8. Cube root of 8 means what number times itself 3 times will give you 8, and that's 2. You can also use a calculator. So g of 16 is 2 plus 1, which is 3. And what do you know? That was our original input. Full circle. So it says, if she gets her original number, she is pretty sure that the 2 equations are inverses. I was very careful on my first page to do my work correctly, so I do know that this is the correct inverse of f. But just to verify further, if I choose an input and if I put it into f and then I take that output and I put it into g, I should come full circle and get back to the original input because g is the opposite of f. it undoes it. And if you guys remember from your packets from last week, the coordinates are always flipped for the inverse. So basically, if you have a table of x and y values for f, your original function, to find the table for its inverse, you just flip the coordinates. So the x values become the y values and the y values become the x values. Because the backwards function, the inverse always undoes, works backwards, and it comes full circle to the original input. Okay, so letter B, it says Adriana wants to find a shortcut to show her work. She knows that if she chooses her input for f of x to be 3, which is what we did, she can write the output as f of 3. Next, f of 3 becomes the input for g of x, and her output is 3. Since f of 3 is the new input for g of x, she thinks that she can write this process as g of f of 3 equals 3. Does her idea make sense? Why or why not? So basically, she took f of 3, we got 16. She plugged that into g, and she got 3. So yes, that makes sense. It's exactly what we did in letter A. Since g of x is the inverse of f of x, it worked backwards to get the original input of 3. Her friend, such weird names, I have no idea how to pronounce this, Semitra thinks she could also write f of g of 3. Is she correct? Why or why not? So notice they look similar, but she switched the f and the g. So this means she's going to plug 3 into g, then she's going to take that output and plug it into f. Well, basically she wants to plug 3 into g first and then plug into f. So the reverse order, let's see if it works. So if I take g of 3, I get the cube root of 3 over 2 plus 1. 3 divided by 2 is the same as 1.5. So this is going to be a really ugly decimal in my calculator. I'm just going to keep it as is, the cube root of 1.5 plus 1. Then she wants us to take that and plug it into f, just the reverse order of what we did. So f of cube root. I'm going to plug it in for x right here. Now I'm going to continue my minus 1 and my cubed. I'm going to see what happens. So here my 1 minus 1 goes away. Because that's 0. I'm not going to write this left side anymore, it's too long. So cube root and cubed cancel out, and you're just left with 1.5. 2 times 1.5 in your calculator is 3. So did we get the original input? We originally plugged in 3, got this ugly thing, plugged in the ugly thing, and got 3. So yes, hers works too. And the reason why it works is because if G is the inverse of F, then F is the inverse of G. They're backwards of each other. So it doesn't matter the order that you do your plugging in. They're always going to undo each other. Now granted, this way was a lot uglier because the cube root of 1.5 is an ugly decimal, but it ended up working because it undid it to get the original input. They are inverses of each other. So order doesn't matter. They will always undo each other. Will this strategy for testing inverses work with any input? Yes, we did not have to use 3. You could have used 4, -10, 100, any input that you wanted, and it will work. It'll come full circle. So we have one more problem to do together before you work on your own. Remember, you have 2 days to work on this assignment. So 543, Statler, her teammate, is always looking for shortcuts. He thinks he has a way to adapt Adriana's strategy, but wants to check with his team before he tries it. If I use her strategy, but instead of using a number, I skip a step and put the expression f directly into g to create g of f of x, and g directly into f to create f of g of x, will I still be able to show that the equations are inverses? So basically what he's saying is, instead of just picking a number to plug in, why don't I just plug the equations into each other? What do you think about Statler's changes? What can you expect to get out? Well, here we expected it to come full circle to have the original input. So if you start plugging them into each other, what do you expect to get? You should expect to get the original input. What's the original input for f of x? It's x. What do you think about his changes? I know that they're gonna work. You guys are probably skeptical at this point, so I'm not gonna answer the question, but what can you expect to get out? The original input, which is x. So from now on, when you're asked to prove that 2 equations are inverses of each other, you have to use this method, and this method is called composing. It's when you just plug them into each other. So we're going to take g and plug it into f anywhere we see an x, and we're going to take f and we're going to plug it into g anywhere you see an x. And basically, since they're backwards functions, they're just going to completely undo each other. It seems complicated, but I promise things will cancel out. They're supposed to undo each other, and then we should be left with x in the end. So let's try f of g of x. We're going to do this one first. We're going to take g and plug it into f. So I'm going to take g and plug it into f anywhere I see an x. So that means I'm going to start writing my f equation. I'm going to stop when I see the x, and instead of writing x, I'm going to write all this junk. And then now that I've written this whole equation, I'm going to continue here. So -1 cubed. I'm going to continue my work. What cancels out first? Make sure you are using Pemdas when you are simplifying or evaluating. 1 minus 1, and you should be doing this one step at a time. I need to see all your work step by step. What cancels out next? Cube root and cubed. So all that's left is x over 2. What cancels out next? If you have multiplying by 2 and dividing by 2, what are you left with? I told you it wasn't going to be that bad because they're backwards of each other. They will just completely unravel and everything will cancel out. So I'm going to show you that canceled out. Then we did that. Then you're left with x. You have to do the other way as well. Okay, so now we're going to do g of f of x. We're going to take f and plug it into g anywhere you see an x. I'm going to start writing my g. I'm going to stop when I see the x. I'm going to write this instead. So all this f goes in the numerator. Then I finish this. Divide by 2, add 1. Again, things should unravel just like this. What cancels out first? 2 divided by 2. What cancels out next? We have cubed and cubed root. I said that in backwards order. Cubed root and cubed. And then we have -1 plus 1 is 0. So it doesn't matter what order you start in, but you have to plug them both into each other. You have to do both pieces of work. You're going to notice that the steps are very similar, but they might be in opposite order. See, here our 2's canceled out last, but here they canceled out first. So be careful that you're using Pemdas when you're simplifying. Okay, So since we both ended up with the original input, I know for sure that these are inverses of each other. Describe your results. Got x for both, which is the original input. Does his strategy show that the two equations are inverses? Yes, because they undo each other. And you are left with the original input of x. Just like here, we were left with the original input of 3, but now we can just generalize it by plugging the equations into each other. So again, this is called composing. When you're asked to compose, you're plugging them into each other. F of g of x, g of f of x, okay? One more thing that I want to add is a dead giveaway when you're doing this. A dead giveaway that they're not inverses if things don't start unraveling. So if you feel like you don't see anything that cancels out right away, it could possibly be that they're not inverses and you need to stop, okay? So here, you're going to compose your functions. You have 3 examples here before moving on to 546. So you're going to plug g in a f and f in a g, and you should be left with x. And if you're left with x when you're simplifying, you know that they're inverses. You say yes. If you see something going wrong when you're plugging g in a f and they don't start canceling each other out and you're not left with x, don't do the other way. You know that it's a no already. So if it's going to be a no, you don't have to do both. But if it's going to be a yes, if you get x in both, you have to do both ways. Plug g in a f and f in a g. Same thing here, same thing here. Again, if you don't see, a clear sign that things are going to start canceling out, it might be a good idea to conclude that they're not inverses. But you can always ask me questions if you have any, okay? So then in the review preview, look, you have a review of your function machines, pretty much a review of this stuff, and you're going to be composing on your own some more. Again, you have 2 days, so please submit PDF pictures of this by tomorrow. I believe tomorrow is April 30th at midnight. Please comment below and on Google Classroom and enjoy the next 2 days. Bye.